This is the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Will.
And we'll be taking you through the latest and greatest in data science, without taking ourselves too seriously. This time, Will and I discuss the need for better training data, the limits of model interpretability, and the possibility of an AI winter.
So, Triveni, I think oftentimes on this podcast, we focus a bunch on algorithms, modeling, applications of data science and AI, which is kind of the sexy stuff. But I think sometimes we maybe neglect thinking about the data, which is definitely a big part of data science, right?
So it's right there in the name, Will.
It's right there in the name. I found this piece by Matt Wilder. It's called The Side of Machine Learning You're Undervaluing and How to Fix It. The key thesis of this article, again, going back to the data, is that basically, if you think about machine learning and AI, there are two components. There are the models, the math, the algorithm. That's one component. Mm-hmm. And there's also the data, which you could think of as the analogy he makes is the fuel that powers this. So you could think of the models as the car, right, and the data is like the gasoline that powers the car. And I think it's probably maybe a point well taken. I guess I'm interested in your take on this. Are we really undervaluing data quality or not?
Yes, we're definitely undervaluing data quality, right? This is like, this is one of those things where that whole garbage in, garbage out thing really applies, right? If you're feeding terrible data, your algorithm on the other end is going to be terrible. So stop focusing, or maybe spend less time trying to come up with the most amazing neural network that has like 64 layers trained on it, and maybe focus on getting some better data in your system first.
Yeah. And I guess we should clarify, a lot of this article is focusing on high quality training data. So the distinction between like data quality broadly defined. So if you think about, a data table and you have, extra commas or delimiters or, there's just characters in this table that are somehow not what you want and messing up the format of your data, that we could consider messy or low quality data. But again, Matt here is really talking about training data. So again, when we think about supervised learning, where we teach an algorithm how to learn from known classes of examples, in this case, we need to have high quality labels to begin with, right? We need to have that high quality ground truth to begin with.
But I think the problem is that there's not enough emphasis placed on having good labeled data because it's not sexy.
Yeah.
Right? It's not fun to do.
Yeah. And that's probably a theme of this podcast, right? Is making the unsexy thing sexy. So like data quality, not sexy, but it should be. And again, thinking about last week, this idea, remember we talked about ethical code, lowercase c, and just that idea of, a best practice should be thinking about subpopulation analysis. If you don't do it, you're messing up. Yeah. It's not really sexy, but it should be.
Well, no, I mean, not even sexy. That implies sort of like a, attraction and like a fleeting thing. I mean important. I mean a part of your pipeline, a part of your practice. I've seen clients come to me. I've worked with groups that say, hey, we have this big question we're trying to ask, but we have 2 million records of data and 100 of them are labeled correctly. Mm-hmm. And there's nothing you can do with that. Go back and label at least like 10,000 more records for me. And so being cognizant of the fact that like these algorithms they're not magic boxes. They still need something. And you can't really just rely on a lot of unsupervised techniques. Sometimes you need to put in the really brute force, boring work of labeling data.
Yeah, no, that's fair. I think particularly in some of my previous jobs where I was focusing even more on model building, clients would oftentimes say, we want to build this model. And we would ironically, even though we were being hired for our computer science and algorithm knowledge, you're right. We would spend a lot of time thinking about the data, using Mechanical Turk sometimes to help us supplement data sources. So that's fair. But it made me think of last week's podcast when we talked about BERT and kind of the way in which BERT is using, as I described last week, unsupervised and supervised learning techniques. I think they're being a little bit more thoughtful and more efficient about how they gather training data. And so I don't have the answer to his question, but part of me is kind of optimistic that, we don't need to think so explicitly about the need for training data because we'll just come up with more intelligent ways to obfuscate that need going forward.
No, but I think we need to have still good labeled data for supervised techniques.
I guess you would say, and I think you would probably be right, that there's an ethical component to this too, right? Like the curation of those training labels is relevant.
Yeah, we want to at least know, is the data we're feeding into even an unsupervised algorithm still aligned to what is reality, right? Or is it this data that came out of nowhere? Someone needs to check the data, right? And at least when you're labeling data, you're confirming that, yes, this is a picture of a cat. yes, this is a picture of a dog.
So there's human judgment going on. But I think, I don't know, I hope that, I guess maybe I'm lazy because, also a point the author makes is that, we should think intentionally about our data gathering practices. So if you're an organization that wants to be powered by AI, the author makes the point that, AI training data is not just any data exhaust. I love that term, data exhaust from an organization. But it's not just that. It needs to be kind of intentionally collected so that it can be fed into a machine learning model. It sounds good. It sounds right. I don't know. Again, the laziness in me is like, well, maybe we can adapt our methodology. And so we can just take kind of whatever data exhaust an organization gives us and find insight and knowledge in it. Like, that's the goal. I guess, again, I'm being too naive here, perhaps.
Well, I think, I agree that there are companies who are getting into this AI space and saying like, okay, we need to do this. So whatever data we have, we're just going to find a way to work with it. Here's 100 labeled records, right? And maybe you're in some rush to showcase value, but long term, your strategy needs to include better inputs to your data so that you have the labels sort of pre-populated, or whatever data you're getting out of your database is actually useful.
Yeah, that makes sense. I guess this idea of a data pipeline, like a data-driven organization should have solid data pipelines. So
right.
Good ways to source data, good ways to use that data, and good ways to kind of close the loop and come back around and assess the quality of your models. That makes sense. That actually reminds me of another article I want to talk to you about, Triveni.
Oh, do tell.
So this idea of a responsible organization needing to, again, close that loop and think about not just the model performance, but we talk a lot about model interpretability. There was a cool article just published in The New Yorker called The Hidden Costs of Automated Thinking. And the author begins this by talking about medicine and discussing a wakefulness drug called Modafinil. And so, when you buy drugs in that small little pamphlet, like the paper pamphlet that has all like the fine print in it?
Yeah.
So the author writes that at the bottom of that, it says, the mechanisms through which Modafinil promotes wakefulness are unknown.
Huh.
So basically, the author then goes on to talk about the medical space and how medicine actually has an interesting history of putting applications or drugs into practice that are effective, like they kind of achieve the purpose, which is somehow making someone healthier, but we don't initially know what's, the root cause of how that efficacy works.
Mm-hmm.
And so the author makes parallels between medicine and now AI, where, as we've discussed at length, sometimes algorithms are providing insight, but we're not really sure what's the underlying cause of how they're providing that insight. And the author also brings up this interesting point, what they call intellectual debt. So this idea that, we have the cause of the drug or we have the cause of the AI, but then we need to, in the forward, kind of pay back that debt by figuring out the underlying mechanisms that are driving that, right? So in the future, we know that Modafinil promotes wakefulness, but in the future, we need to figure out how exactly that happens. And they make some interesting points as to why we should figure out how that happens.
Yes, but I don't think we should figure that out for everything. I mean, I think
that's counter what I was expecting from you, Triveni.
I know you expect me to solve it all.
Yeah,
right?
I expected you to be deep in the interpretability bandwagon.
Well, I am. To be fair, I am very pro interpretability, but I'm also pro not wasting time on things that don't need to be interpreted. Okay. So, when it comes to things that have ethical implications, I need to know why you think this person is going to jail, right? Like, what's going on in your model? We need to figure this out. But when it comes to, hey, I predict that you're going to want to buy this blue shirt because you bought these yellow pants, I don't really know that I care about why you made that decision. Maybe the business, up top cares.
Yeah, so playing devil's advocate here,
I
think I kind of agree with you. But the point the author makes, which I thought was one that I hadn't foreseen, was this idea of interactions are a reason why intellectual debt is a problem in the future. Yeah. So to explain what I mean by that, if you have one drug that you're taking that helps you in some way, and it kind of has the desired effect, but we don't really know how or why, and then you start taking some other drug that also helps you in some other way, but we don't really understand the underlying root cause. Because we don't understand how those drugs are working, then when you start taking multiple drugs, there might be some strange and problematic interactions between those drugs that can be really problematic.
Right.
So then the author talks about the flash crash of 2010. Are you familiar with the flash crash of 2010?
No.
This was a period, I believe it was only a couple hours in 2010 when the stock market lost over $1 trillion worth of value and then quickly regained it all. And this was largely attributed to algorithmic traders.
Mm-hmm. Yeah.
But so that idea of, things are happening, we don't really understand the root cause, and then they're interacting in a really powerful way, and then those interactions can spiral out of control in a negative way.
Yeah, but again, pushing back on this, yes, we should be interpreting our models. We should be able to understand why a model made a certain decision. But if you're saying that there's interaction effects, just being able to interpret a single model is not going to unearth interaction effects for you. There's like a whole slew of tests and statistical analyses that need to happen to be able to suss out that interactivity. And it requires the algorithm maker or the scientist to actually have a sense or understanding of the ecosystem, right? So like researchers who develop new drugs have a sense of like, okay, this is a drug affecting the renal system. And I also know that this other medicine affects the renal system in this different way, whatever it might be. And so if we just say like, oh, we're going to start interpreting our models, but not understand them in a certain context, then it's just as like inefficient.
Yeah. And that's actually a good point that I hadn't thought about at all, which is there is, I think, a difference between how we explain our models and how they actually work too, right? If you think about, how I would explain to someone that I identify you as Triveni and Anna as Bob, I have my own theory in my mind, but like what's actually happening literally in my mind is, I would guess, different than what I would explain verbally in English.
Yeah, and I think there are like new developments in interpretability and the sort of like underlying mathematical principles to get at those questions. But again, they're very mathematical. And so where's the link between mathematically interpretable to say variable X is the driver of this prediction, and what does that mean in your actual
I've always
reality?
found that to be a hard trade-off when I'm trying to explain the results of my, let's say, algorithms, right? Because like literally what you're saying, like when you think about something like feature importance with regards to random forest models, which I believe we're going to talk about later on this program.
Yep.
That's something where kind of largely you might explain to a more layperson like, oh, it's just like some sense of the proportional importance of this feature towards the prediction. But if you actually get down to how that is calculated mathematically, it's going to take you minutes, hours to explain that to someone. And so you don't want to leave something out, but there is definitely power in kind of glossing over. So that's a tough trade-off as well.
Yeah, and I would argue that just because something is an important feature in a model, that doesn't mean that's what's driving the outcome. Right? So like what is a prediction? A prediction is saying, I think this is going to happen. And I happen to get it right. I think that it's going to rain tomorrow. Okay. And it did. But that doesn't mean that whatever feature was important in my model was the real root cause of why it rained. And so it's one thing to say we should be able to interpret our models, but it's another thing to say by interpreting this model, we've also figured out the underlying cause of what's happening.
Yeah, no, that's true. I mean, and this gets to a hot topic for sure in the AI space. I believe there's a whole branch of AI called XAI now for explainable AI.
Yep.
And definitely causality in AI is really growing too. But I think it is perplexing to me. And so this is now me taking off my devil's advocate hat and more maybe speaking my mind. I definitely think we need to have responsible AI systems, but also it's kind of a catch-22 because we're designing these systems that are supposed to be definitely more efficient, but in some ways more intelligent than we are, right? We're saying churn through billions and billions of data points and put together, find underlying correlations, patterns that I myself as a human brain can't detect. So if we ask a model to essentially reason in a way that's more intelligent than us, I don't even know if it's fair that we expect the model to then be explainable to us.
Oh, like their mind is so
you think
much
of it as like
more
an alien or something, right?
Yeah.
So
I don't know if I agree with that. I think like at the end of the day, what is an algorithm? It's a series of numbers and like it's math.
So we should be able to
we should be able to at
parse
least
out how
understand it. Yeah.
Fair enough.
Yeah.
So the author actually concludes the article on this point. We worry a lot about what happens when AI goes wrong. So we talk on this podcast a lot about biased predictions, for example. But the author says we should worry more also about what happens when everything goes right. So when these AI systems are so intelligent, they're making really strong predictions. But when that happens, and maybe we're incurring intellectual debt, they're making good predictions, but we don't understand how they're making those predictions. So suddenly we start implementing these systems more and more, which is kind of the promise of AI. But again, the author says because of these interaction effects, because of this intellectual debt, there could be some real negative consequences coming down the road. And again, we need to be wary of them. All right, now it's time for In English, Please, the part of the program where we break down complex data science topics in plain English. Triveni, could you please explain random forest models to me in English?
Yeah, sure. So random forest models are a very popular form of algorithms that folks use across the board. And it sounds complex, but it's actually really quite simple. So when you think about a random forest, it actually breaks down into multiple little algorithms called decision trees. Now, a decision tree is something that we use every day. Should I wear my rain boots or not, right? And so, is it raining? Yes, then I should wear my rain boots. So these little decision trees actually add up to create a larger forest. So if you think about a data set where you're trying to predict, is this piece of fruit an apple or an orange? It's going to look at the color and it's going to say, is the color red or is the color orange? And based on the answer to that question, it will then make a decision about what prediction it's going to make. So in a random forest, we take all of those decision trees and we put them all together, put all those trees together into a forest, right? Literally. But the random part comes from using random subsets of data and features for each decision tree. So by doing that, you're actually preventing overfitting because you're able to look at a wide swath of data in a lot of different ways. And then once all of these different trees have made their decision about, I predict this to be an apple versus an orange, all of those trees, their decision gets, averaged out or voted out to say the majority of trees are voting for apple over orange for this prediction. And so random forest is generally a really good model in that sense. So I generally suggest folks to try out a random forest as a baseline, especially because it can outperform a lot of other models and algorithms out there, especially when you have a lot of features.
Thanks for explaining that in English.
So there's this meme out there, right? Winter is coming, which comes from Game of Thrones. And you'll see actually now a lot of articles coming out by tech writers saying an AI winter is coming. And it's an interesting concept of what is an AI winter. It's not something that we haven't seen before. So historically, AI has gone through these ebbs and flows of development. And in fact, if you look at the history of development of artificial intelligence, we've kind of dropped off in periods of time where AI wasn't being really developed or pushed forward. And then, we reemerge from this winter and then create these great new techniques that sort of start taking over.
So when were these AI winters? When and where were they?
Yeah, so actually the first winter hit right around towards the end of the 1960s. There had been this period of excitement and growth around the idea of AI brought on by Alan Turing and all these new developments going on within various countries. But when AI research couldn't actually deliver on its promise the first time around, a lot of funding was pulled back. Mm-hmm. So we had this winter where there wasn't really much going on. And then again, in the late 70s, early 80s, we had a resurgence. We saw a lot of different countries, Japan and the US and the UK, working on new technologies. And again, these folks were unable to deliver as promised. So it went through this winter, right? This was the mid-90s, all the way through most of the early 2000s, where AI was really just a dead term. And it was just some futuristic thing that would never happen. So we re-emerged out of this second winter in 2010 or thereabout, where new advances in computing power and algorithms allowed us to actually develop new techniques for AI, like neural networks. And now we're not sure if winter's coming again.
But so why would winter be coming again?
Well, the authors of a lot of these articles, and there's a lot out there on the internet, there's this whole the end is near kind of vibe, are arguing that, well, we've sort of reached the upper limit of what we can do with neural networks or more advanced computation because the data we have is finite, right? And the only way for these models to actually develop and to get better is to feed them more data. And as we know from our earlier discussion, there are lots of issues around data. And then, the second reason, of course, goes back to why we had the first two AI winters. People aren't delivering on the claims they're making, right? Elon Musk is saying we're going to have autonomous driving cars by 2018. Well, it's 2018 and we don't have autonomous cars.
That's fair. I think I would definitely disagree. My understanding of previous AI winters is that in the past, AI, so artificial intelligence, has been a pretty academic pursuit. But at this point in time, I mean, you and I work in the space. I think that AI has reached, big business. It's reached the enterprise. It's reached, obviously, small, powerful startups that are changing our world. But it's really become embedded. And I think it still has room to grow, right? Like, as we know, there are better and more embedded applications that can be made in these large organizations. But I think, once big business gets a taste and they see that AI or data science or machine learning or whatever you want to call it is really making a positive impact, I think they're not going to stop. And I think in public discourse, maybe we're disappointed that we don't have self-driving cars yet, but I don't sense that Tesla is going to stop trying.
Yeah, I mean, Tesla's not going to stop trying, but I would argue that big businesses, have this fine line to walk of trying out the newest thing in data science or like moving towards a strong data science practice and actually delivering some value back into their company. And so if businesses or companies are going in and saying, well, we're going to just like do data science and all of a sudden our ROI is going to be 300%. Well, okay, hold on. What are you trying to do here?
Yeah, that's true. Internal funding follows the hype. But I mean, data and the power of data to transform business, it's been a promise that's existed forever. And I think it's been a promise that's been delivered on forever. Like, the name is currently AI, but data analytics and business analytics and SQL databases have been being used to good measure inside large organizations for a long time. And I think that people who are running these businesses, they know that. They see the potential.
Yeah, so maybe it's not AI winter doesn't have to mean data science winter, right? AI in itself is such a widely defined thing, right? The way we talk about it a lot on the podcast are very practical implementations. But I think, again, the public discourse is Terminator and auto-driving cars and all of that. I would also argue, though, that an AI winter might be coming only in certain parts of the world. So I would actually argue that businesses in the U.S. and the West, right, are generally tied to showing some sort of value of their work. And where they're not able to show a return on that data science or AI stuff, they're likely to start putting it to the side. But there are places like China where the government is heavily investing in AI. So China is investing a lot of money and effort into AI broadly in their country, right? So startups have a lot of freedom to work on new things. There's a lot of data being collected on users, and they're actually really pushing forward to become an AI superpower. And this is actually an argument made in a book by Kai-Fu Lee. So maybe there is an AI winter coming, but it's probably not a global winter. I think that we are going to see new developments in AI in places like China and parts of Africa where data science is really picking up. We'll see an AI winter in places where businesses have this need, startups have this need to show some value back to their investors quickly, and they're not able to dig in and do that research.
Yeah, I think 2 points you made there. I mean, the world, because of AI in part and because of information technology and the internet, obviously very globalized, very interconnected. So to that point, if China is still accelerating, I don't foresee the U.S., metaphorically taking its foot off the gas pedal here because of international pressures. So yeah. I think that's another good point that you make. And then also, just to go back to it too, I mean, right now, this is the data science podcast, but, maybe in a few months it'll be the AI podcast. And I do think that there are semantics to discuss and how these terms can have slightly different meaning. And I know some people interpret AI and ML, so machine learning, differently. But by and large, data science, data analytics, business analytics, data modeling, machine learning, AI, they're all, different sexy terms that are catching the public attention. But I think internally for people who are using these tools and doing work in the space, they really understand at root what's happening, right? Computer science principles, mathematical principles, data quality, these are things that are always important. And so I think, again, the authors of these pieces, maybe need to do a better job of differentiating between, well, maybe the public is going to enter an AI winter where everyone's just discouraged about the use and promise of AI, but really at heart by the practitioners, I don't see the AI winter coming.
Yeah, I think that's right. I mean, it's, again, why have we had 2 AI winters in the past? It's because there's been overpromise and underdeliver. Well, businesses now don't need to be overpromising that we're going to do some AI that's going to just like change the face of our business. No, they're recognizing that we need to be using data more strategically, and there are good tools and resources for me to do that. But I don't need to be, pushing myself towards creating the like one size fits all perfect algorithm that's going to fix every line of business I have, right?
It's probably an example of where media is kind of also just perpetuating a cycle here. What I mean by that is, it probably sells papers to say that, AI is coming and it's going to completely revolutionize your world.
Right.
And then wait a couple of years and say, a new newspaper headline, AI has totally failed. AI winter is here, down with AI.
Right.
People appreciate these extremes when in reality, I hope and I think from what I see, there's a slow and steady increase in progress here.
Yeah, and I think the media and journalism in general has this sort of responsibility to not sensationalize, but on the other hand, practitioners have a responsibility to not let themselves be sensationalized. So some researcher will put out some algorithm that, does like a very minimal natural language processing mechanism. And then the articles are, oh my God, we have robots that can talk to us now. And the researchers don't really go back to say, whoa, hold on, right? Because they want the hype, they want the accolades, which is fair and totally understandable. But I think moving forward, if we're going to prevent an AI winter, it has to be 1, not overpromising, and 2, not over-expecting from the other side of things. Before we head out, we're going to do the banana fact of the episode. And bananas may have been the first cultivated fruit in the world. Archaeologists have actually found evidence of banana cultivation in New Guinea as far back as 8,000 BC.
That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Triveni.
It's been great, Will. See you next time.